Welcome to the third module of the Arduino badge. In this lesson, we're going to learn about basic programming structures to help you build more complicated programs in Arduino. For this module, all we're going to be doing is order programming on our computers. As a result, you do not need any additional setup as from module 2. As we are using the button circuit, the initialization of the pin number and the pin mode should be the same as what you had before. As well, we're going to set up some variables. So variables store information that we can use later down the track with the program. And so to do this, we actually need to set them up. And to do that, we're going to do int button count is our first one, is equal to 0. So the button count is the name of the variable that I'm allocating, and the 0 is the value that I'm assigning to that variable. Finishing it off with a semicolon as well. This one will actually count the number of button presses that I'll be performing. The next one we're going to do is int button states, which will record the state of the button press. The last one we're going to set is last button state, so that's going to be int last button state, and this will record the previous state of that button. These will be used in the program, as you'll see in a moment. For the first part of the main program, we're going to be checking for button presses. This means that we need to check if the button has changed state from the previous state. In order to do this, the first thing we're going to actually do is make sure that we can actually read the current button state. To do that, I'm going to set button states equals to digital read and then button pin, like so. The next thing to do is to set an if statement to check if the button state is equal to the previous button state. So to do that, we're going to set if button state is not equal to last button state, because what we want is the button state to be changed from the previous one. Inside there, we also need to check if the button is indeed pressed. And so to do that, we're going to say if button state is double equal to high. And this checks if the button is indeed pressed as well. Lastly, inside the second if statement, we can now increase the value of the button count by 1 because that's accounting for a registered button press. To do this, we can do it in two ways. First is we can change the value of button count to add it by 1. And to do that, we're going to get button count equals to button count plus 1. Alternatively, you can also shorten and simplify it if you're just adding it by 1 by doing double plus. Lastly, for the button presses, we're going to add a delay of 50 seconds, and this is to ensure that the system program remains stable. As well, we're also going to put in the last button state into here, and that's because we are checking for the previous state in order to reference it in the if statement. For the second part of our program, what we're going to be doing is checking if we've pressed the button 4 times, then the LED will consequently blink 4 times. In order to do this, the first thing we need to do is check if the button count has reached a number 4, which means that we've pressed the button 4 times. So we're going to write an if statement with button count equals to 4, and that will check if the button count has reached a value of 4. The next part is we're going to write a new structure called a for loop. And what this does is it allows us to iterate the same set of code multiple times. And in this case, we're going to be blinking the LED multiple times. To do this in setup, what we need to do is write for. We're going to set up a variable inside the for loop. And in this case, I'm going to set it as I with an integer, followed by a semicolon. The second term argument in the for loop is going to be the function that we're going to be checking for, and in this case it's going to be I less than 4. So if I reaches a value of 4, the for loop will stop iterating. Lastly, at the end of each loop, we're going to also increase the value of I such that it eventually attains a value of 4. Inside the for loop, we can now blink the LED. So this is the same as the program that we've written in the first module number 1. So it's digital write LED pin high, add a delay, and in this case I'm going to add a 500 millisecond delay or 0.5 seconds, and then I'm going to turn the LED off, lastly followed by another delay. As well, Since we've pinged the LED to blink 4 times, the last thing we can do is reset the button counter by setting it to a value of 0. Now that our program is done, we can simply upload the program to the Arduino. And there we go. We've made a simple button counter using slightly more complicated programming structures. As you can see, if I press the button once, nothing happens, but if I press it 3 more times, the LED will blink 4 times as programmed.